Problem 8 says, your patient must receive 1.4 milligrams per kilogram of a drug. Oh, that's a rate of administration of the drug. This is a drug that the amount a patient gets depends upon what the patient weighs. Your patient must receive 1.4 milligrams per kilogram of a drug. Okay? So the patient needs to get 1.4 milligrams of the drug for every kilogram of their body weight. The drug is available in the form of a liquid in which each milliliter contains 30 milligrams of the drug. Okay? So each milliliter contains 30 milligrams of the drug. That's the strength of the liquid, isn't it? There are 30 milligrams in each milliliter. If your patient weighs 75 kilograms, how many milliliters will you administer? Mark the correct dosage on the syringe. So we're going to start, as we've done before, with that patient's weight so that we can cancel the kilograms, and if we did that arithmetic, we would then know the proper number of milligrams that a patient of this weight should receive. Now we want to put in our strength equivalents so that we can get rid of the milligrams and end up with milliliters of the solution that we would need to inject. And it says that 1 milliliter contains 30 milligrams of the drug. So if we take 75, multiply it by 1.4, and divide by 30, we get an answer of 3.5 milliliters that should be injected. And if we look at our syringe, this happens to be a 5 milliliter, a 5 cc syringe. Where 3.5 milliliters would be, well, let's look at that syringe. We have a 3 and we have a 4, and each of those marks between must represent 2/10. 3.2, 3.4, 3.6, 3.8, 4 milliliters. So if we need 3.5, we would have to go halfway between the second and third small mark that's between the 3 and the 4. That would be approximately 3.5 milliliters. And if we drew that amount of liquid out, injected it into the patient, a 75 kilogram patient would be receiving the correct amount of medicine that was to be administered at a rate of 1.4 milligrams to every kilogram of their weight.